Establishing wireless communications between vehicles and infrastructure could have a huge impact on the way we drive.
Americans spend approximately 4.8 billion hours in traffic each year. We get into almost 6 million crashes per year. Wouldn't it be great to bring those numbers down?
Car driving video games are great, except the only car that crashes is the one that I drive. And the cars that the computer drives don't crash, and it's because those cars know exactly where they are on the road, and they know exactly where every other car is on the road. And that's what the potential is for connected vehicles, to know every moment, every second, every tenth of a second, where I am on the road and where every other vehicle on the road is.
Everything's being connected via networks. You have your cell phones, you have toaster ovens, you have refrigerators that are actually all talking via networks. It's very nice that your refrigerator can tell you you're out of milk, but when your car can tell you another vehicle is about to impact you and perform the appropriate safety measures, that's a very big benefit.
In the past, we tried to make occupants safe in their vehicles during a crash. Now we're working on preventing the crashes altogether.
The U.S. Department of Transportation, in cooperation with the automotive industry, has the goal of enabling networked wireless communications among all types of vehicles. We are promoting development and deployment of wireless connected vehicle test beds and technology in the public and private sectors.
These test beds offer developers the necessary infrastructure to test and demonstrate connected vehicle technology, applications, concepts, and products. There's no need for investing in costly support equipment and no need for complex testing arrangements with roadway operators.
It's also, and very significantly, a place where you can actually get out on the road and try stuff and see how it works in this real world. This is not a laboratory. This is a real world environment. These are real streets that you'll be driving on. These are real traffic signals that you'll be reacting to.
We can simulate things on a bench, but there's just nothing like being in the real world. If we have infrastructure talking to the cars, I mean, there are new safety algorithms that we probably haven't even thought of yet that we can basically develop, on the test bed.
Hirschmann is developing antenna technology for use in the vehicle testbed. The testbed actually is the real-life scenario for us to test these components, these parts of the whole system, to see the overall vehicle performance, the overall system performance.
DENSO has used these connected vehicle test beds to do a lot of development and assessment on a number of occasions to actually perform experiments and customer type level assessments as to how effective this data exchange from the infrastructure to the vehicle can be used on a connected vehicle basis.
The test bed has an experienced and highly skilled staff who are familiar with connected vehicle technology development and can help users test even the most complex scenarios.
There's a number of test beds that are in place right now. The Michigan test bed is in Novi. The Turner Fairbanks Highway Research Center in McLean, Virginia. There's a test bed in Arizona, test bed in Florida, test bed in California, test bed in New York, and in Minnesota. And they're all connected, and we're affiliating them so they work together and we're able to share information, share data, and share lessons learned amongst all of them. We currently have a fully operational testbed in Novi that encompasses the proof of concept testbed and the geographic area that was covered in the proof of concept. Telegraph Road is fully operational near Novi for a signalized corridor. Turner Fairbanks Highway Research Center in McLean, Virginia, the Saxton Operations Laboratory, is fully functional today.
Here at Saxton Laboratory, we conduct closed-loop testing and modeling of various elements of a connected vehicle system in order to understand how these elements will react when deployed in real-world environment.
The capability we have here at the Saxton Lab is the ability to take concepts, turn them into engineering designs, test those designs to see if indeed they work, and then put them on the road and test them at our intelligent intersection and see how well they work.
The back-end services where information collected from the connected vehicle test beds is stored are based at a fully equipped data center in Oak Ridge, Tennessee. We have servers running 24/7 to collect and process connected vehicle data. We run on 99% uptime and have a reliable system that the research community can depend on. The connected vehicle test bed will offer additional support services including virtualized server systems for Security Certificate Management System or SCMS, Local Certificate Distribution System or LCDS, improved IPv6 functionality and capabilities, new roadside equipment or RSE supporting improved messaging, logging, and IPv6 gateway functionality. Also included are vehicles equipped with a universal connected vehicle device mounting system and new mobile RSE units that allow for private testing or for testing in atypical locations like a parking lot.
We see the ITS test beds as valuable resources for training and education about ITS technologies, a place where students can get a hands-on demo of signal phase and timing applications, or where researchers can see how connected vehicle technology will work in a real-world environment. Maybe try out a new application they've developed.
The vision for our test beds is for them to become an incubator for innovation, to fill in the missing pieces required to run a fully operational and stable connected vehicle environment. We want to encourage developers to go beyond proving that the technology works. We want to provide support in advancing and refining the technology to make it function better and make it easier to implement. The Connected Vehicle Test Bed is where hardware developers can test their equipment in a live environment. It's where application developers can test message transfer capabilities between vehicles or between vehicles and the infrastructure. There are many possibilities to test components of a complete connected vehicle system. We encourage everyone from a developer to a tinkerer to come take advantage of what the test bed has to offer.